Have you ever encountered a puzzling issue in your code that just doesn't seem to make sense? If so, you're in the right place. Today, we're diving into a curious case involving the setAbs function in C++ and why it might not be giving you the result you expect. I totally get how frustrating it can be when your code doesn't behave as expected. You're not alone in this. Many developers have faced similar issues, especially when dealing with type conversions and precision in C++. Let's take a closer look at the specific question at hand. One user recently asked, why does setAbs of a large unsigned long number return an unexpected value? They were working with the number 948282835798401 and got 948428230579840 instead. Sound familiar? Let's explore this together. So what's going on here? The setAbs function is designed to return the absolute value of a number. However, in C++, when you pass a large unsigned long to setAbs, it first converts that number to a double. This is where the trouble begins. And stick around. At the end of this video, I'll share a crucial tip that can help you avoid similar pitfalls in your coding journey. To understand why the user is seeing this unexpected output, we need to clarify how the setAbs function works in C++. The user is correct that setAbs casts the argument to a double. Next, let's discuss the implications of this casting. Since a double has a maximum integer value of just under 2 to the power of 52, any integer larger than this can lose precision when converted. Now, the user mentioned that the value 9,482,305,798,401 exceeds this limit. Therefore, when setAbs is called, it results in a loss of precision, leading to the incorrect output. To avoid this issue, the user could implement a custom absolute value function that handles unsigned integers directly, bypassing the need for setAbs. In summary, the user is correct that setAbs is not suitable for large unsigned integers due to its casting behavior. A custom solution is recommended for accurate results. Fun fact: did you know that the concept of absolute value dates back to ancient mathematics? It's fascinating how these principles have evolved over time. Now, let's look at the answers provided by other users. An alternative approach suggests that using setAbs with an unsigned type doesn't make sense. The user points out that the original code may not compile due to ambiguous overloads. Instead, they recommend using setlabs, which correctly handles the value and produces an accurate result. Now let's dive into a different answer from another user. An alternative solution proposed by another user is to create your own overload of the abs function. This allows you to handle unsigned types differently than the standard library does. With this approach, calling my abs on an unsigned long will return the original value, while signed values will return their absolute values. This ensures correct handling of both signed and unsigned types. Here's a tip for you. When working with large numbers, consider using libraries designed for arbitrary precision, like GMP, to avoid these pitfalls altogether. And there you have it. Understanding how setAbs works with large numbers can save you from unexpected results in your code. If you found this video helpful, please subscribe for more coding tips and tricks. And remember, keep experimenting and learning.